All right, welcome to the Crazy Hat Chemist. Here we go. We're on the 6th video of 10 on solutions. And today we're going to be talking about molality. Notice that's different than molarity. Molarity is a big capital M. Molality is that lowercase m. Here we go. Molality. Bam! Okay, molality. Here's our definition for molality. Okay, molality is the moles of solute, that's in the lesser quantity, divided by the kilograms of solvent. Notice how this is different than molarity, which is moles of solute, so the numerator term is the same, divided by the liters of solution. So it's the denominator term that differs. Okay, molality is very important because it will tell you how many particles are there. Okay, so molality is moles of solute per kilogram of solvent. So let's do a problem. Here we go. Bam! So, how many grams of sodium chloride must be dissolved in 250 grams of water to prepare a 0.525 molal sodium chloride solution? So first of all, we need to figure out what the solute is. The solute is going to be the sodium chloride. The solvent is going to be the water, because again, our universal solvent is going to be water. And most of the time we're going to be putting things into water, and the water is going to be in the greater amount. The solute is going to be in the lesser amount, and that is going to be our salt, the sodium chloride in this case. So we're going to plug directly into this equation here. That is molality, which I know from the problem is 0.525 molal. And I know the amount of mass of water, but I'm going to convert that 250.00 grams of water into kilograms. So I'm going to divide that 250.00. I'm going to divide it by 1,000. I'm going to cancel out my units, and I'm going to have the number of kilograms of water, and then I'm going to solve for moles of solute. So bam, I just plug that into that equation there that's at the very top of this slide. So I have 0.525 molal is equal to X moles of sodium chloride divided by 0.25000 kilograms. Okay, I'm going to solve for the moles of sodium chloride, and here's the number that I get. It does have 3 significant figures, so that's 0.131 moles of sodium chloride. Now I need to convert these moles of sodium chloride into grams of sodium chloride, because the question is asking for what's the mass of the solute, which is the sodium chloride. So I'm going to convert the moles into mass using the molar mass of sodium chloride. And here's the molar mass of sodium chloride. You should see that the units of moles cancels out, and I am left with my answer in grams. It has 3 significant figures. That is 7.66 grams of sodium chloride. All right, fantastic. I hope that worked well for you. I'm going to give you another alternate path in which to solve this problem, and this is just flat out using stoichiometry. And here's the whole process right here. What I've done is I've highlighted right in the middle there for you, in yellow, the 0.525 moles of sodium chloride divided by 1 kilogram of water. That is what the problem gave you initially, and that is 0.525 molal is the definition of molality, is moles of solute divided by the kilograms. And what's the denominator of 0.525 molal? It's 1. So that's why there's 1 kilogram. And how many grams of water do I have? So I'm going to move on to the left of this equation here. I have 250 grams. In order for the 250 grams to cancel out with the kilograms in the denominator where the yellow is, I'm going to do a unit conversion there between the grams and the kilograms. And hopefully you see that that's that second part there. And I'm still trying to solve for the mass of the sodium chloride, so therefore multiplying by the molar mass of sodium chloride. And this is the number that I get. I realize that it is very slightly different than the previous one there, but that's because there's a rounding issue in the middle there, and we rounded in the middle on the top of the problem there. But I still have 3 significant figures, and I still got a very valid answer, 7.67 grams of sodium chloride. Fantastic. Make sure you pay attention to molality. We're going to be using molality a lot here in just a little bit. Here are a couple of thoughts on chemists. Experiment with a chemist. Ooh, I wonder what that means exactly. So I am the Crazy Hat Chemist, and I'm not sure if this is a crocodile or an alligator. Maybe you can figure that out later on. But that was the 6th video. I hope you're looking forward to watching the 7th video, and that's the Van Hoff factor on solutions. Until then, I'll see you then.